one way to fling a ball. Let's look into some other propulsion systems and figure out which one's the most reliable.
All right, we could get a ball pitching machine. They actually make them for soccer balls, and as far as I know, they're pretty accurate.
I've got an idea for another machine where it actually punches the ball without imparting any spin. That might help.
Okay, well, let's get started and have a showdown. Okay, all of our kicking contraptions should be complete, which is perfect because it's time for the Mythbusters World Cup, also known as calibration tests. We have our official goal right here. Back here, we have the contenders. First off, we have the ball chucker. You're already familiar with the air cannon. And finally, we have our robot kicker.
In 3, 2, 1.
Wow.
That was a good kick. How fast did it go?
58 miles an hour.
Boom! Nice. We're in the ballpark.
The kicking robot was great. It was consistent within 3 miles per hour. Now, moving on to the ball chucker, which, well, is actually made to chuck balls, so hopefully this will be consistent.
All right, we're ready to go.
Tori's already fine-tuned the speed of the tires, and from the very first ball, it looks like he's right in the zone.
God, 59.
It's an impressive display from the favorite, but there's still one to go.
Third.
All right. Going up to 9 PSI.
So it comes down to these last 5 shots.
Fire away.
The shootout is finished, and the result is a shock to everyone.
You know what? Out of all the machines, this one looks like it's the most consistent.
Yeah, I think we all know who the winner was, but just for fun, I calculated the standard deviation.
You and I have really different ideas on fun.
He said fun.
Go ahead.
Okay, this one's 1.22. This one is 2.3. And the winner and still champion, Air Can with 0.84.
Oh my gosh, after all that, we have to go back to the air cannon.
Yes.
But let's not forget that's just half the equation. If the speed going forward is also in doubt, we'd be fools not to fix it. And Carrie's no fool.
So the solution to our speedometer problem is this. It's a tachometer. Now what we're going to do is we're going to brace it with all sorts of clamps that I've scavenged from the camera department. So it's right here against the wheel. We have some reflective tape that's going to make the laser able to pick up every revolution, and from there we can do the math, find out exactly how fast our car is going.
This is it. We have eliminated all the variables. We have the cannon shooting at 60 miles an hour, the car driving at 60 miles an hour, just to show that this ball will drop straight down. This is it. It's go time. Go!
Look, this is a classic physics thought experiment. I mean, you've got something moving, you fire something off of that moving vehicle at the same speed, and ideally it should cancel out. But this is the real world.
Cannon was fired a little too soon.
This is all a bit finicky. I think we're going to have to try it a lot until we get it perfect.
More tests only lead to more disappointment. Once again, Grant's timing is just off the mark. But Carrie at least sees a light at the end of the runway.
I have a feeling that we are very close to a perfect demonstration. We're going to see that ball drop.
With the forward and backward momentum matched as close as they're going to get it, the pressure's on Grant for a perfect release.
I don't know about you guys, but that looked pretty good to me. Let's check the high speed.
Oh my God, it's like a cartoon. It's just in the air, it stops and it just falls.
Look at that.
Fantastic.
I mean, look, it doesn't move at all. It's going straight down.
Dude.
Woo! We did it! We did it! Yeah! Vector edition! Yay! We canceled out velocity!